I lived in New York City for about 10 years where I did pretty tight quarters rigging. And I'm not the guy to teach you rigging from the ground up. This is more going to be me speaking to my experience, more talking about how I ran into these problems and how I dealt with them. Because the urban environment's a little bit different than your suburban or your rural environment. Not all the time. So what do I mean by urban rigging? That's the title. There's a tree in an urban area that's about as urban as it gets. That's on West 77th Street and Central Park West in Manhattan. But if we had to rig that tree, no big deal, right? It doesn't look like there's anything hard about that. Just some benches and a wall, maybe. What I mean when I'm talking about urban rigging, and I probably should have titled the course tight quarters rigging. That's more what I'm talking about that. And you can encounter that. It doesn't have to be in a city. It can be in a rural area. Surrounded by targets, no room to let anything run, no drop zone, brush, the pieces can't come off brush heavy. That's sort of going to be the stipulations for what we're talking about here. Because everything else, you got a little bit more room to work with. And in this sort of scenario, not necessarily limited to the urban environment, but mostly encountered in the urban environment, that's what you got to deal with. You got targets everywhere. You can't let anything run, so you can't dissipate the force, you can't dissipate the weight of that piece entering your rigging system. That's what I'm talking about. Stuff like that. Targets all over the place, minimal drop zone, fences, houses, really like that garage or whatever it is, just like butt up right against the trunk. Stuff like that. I mean, the house is kind of close, but then you got this nest of wires. Nothing but targets. You got to control your swings. Everything's got to be, it's this whole other level of control that is maddening. There's another one just to drive the point home. Again, not that many aerial targets, but we got concrete. We can't just let wood drop. We got a fence that's actually growing through the tree, so we can't get a lowering device onto the tree. Targets, problems, unique situations. Here, there's no ground. We're standing on top of buildings. That's another one I didn't put in my list of things. You know, you got situations where, oh, I'm not supposed to cross this property line because these people hate those people, but I have to get the tree over to here because those people want the tree done even though they hate these people, but they won't let me on their property. Blah, 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 blah. I'm sure you guys have seen that before in all your areas. So, first of all, why do we rig in the first place? Well, we're trying to prevent damage most of the time. We're trying to avoid obstacles. Sometimes it's just to make the cleanup easier, overcome some steep terrain. I've had situations, and I know you guys have had them too, where it's like, it's going to be a lot easier if we put this on a rope, or take a couple minutes or hour or whatever to set some stuff up so we don't have to haul everything up this very steep terrain. And that's something I encounter now in the Bay Area with these guys over here at Plus. Steep terrain, big pain in the butt. And sometimes control. There's a lot of times where it looks like you could just bomb that thing. I don't know about you, you've probably seen it before. I'm a little paranoid. You send something and the wind decides to kick up right then. Cause a problem. I like to control things probably a little too much. You could probably accuse me of over-rigging sometimes. There's a situation, trying to prevent damage. There's nowhere to go with anything. So everything's got to be controlled. Another situation, everything's got to be controlled. We're trying to prevent damage. It's just absolutely nowhere to go with anything. It's crazy. But luckily, in this particular scenario, we had other trees to work with. So thank God. Now this looks like you could just bomb this tree out, call it a day, be done, spend all your time just humping that out of there. And I will say, if it comes down to you taking risks or loading that tree with forces, or just ground labor, then just bomb that tree out and drag it and hop over the fences. You know, don't rig things if you don't have to. This situation, solid tree, other trees to work with, so we actually did spend the time. This was in Scranton, Pennsylvania, actually. I should have wrote down everybody's names for that terrible name. Lovely company. Alan Creed. Anyway, if he's out there, I remembered you, buddy. Yeah, we're trying to avoid all these little fences. You can't really tell in the picture, but that's a pretty steep hill, so rigging for the purposes of making cleanup easier. If that had been compromised at all, though, bomb it out. Bomb it out, cut it up in little bits, hand it off to each other, and then take it out of there that way. Here's a terrain-based one, super steep. More so, the picture doesn't do it justice, so we could have maybe bombed the wood up the hill, get it to land flat, something like that, but I'm paranoid. I like absolute control. The possibility of one of those logs hitting another log or flipping down that hill, you can't see road, power lines, house, all that stuff down there, cars. And here's another one, control-based. I have a pointer here. Right there, it looks like we could bomb a bunch of wood into there, real nice like. It's got a little bit of a slope though, there's a bunch of plantings there, so we're gonna use some ropes. We're gonna make sure that it, although we're taking this added risk of loading trees with forces, we're doing it in a safe way. We'll get into redirection planning, rigging plan in a little bit, but we're maintaining control of this piece. We're slowly introducing that weight by having a butt line there, and we've got to control the situation. Unique factors in an urban environment that you might not encounter in a rural environment. Get odd shaped or limited or cut roots. That becomes important because it's going to maybe affect your game plan. How are we going to load this tree? Like, it has this shape, it has all these points for me to work with, but maybe I don't want to load it in this direction because they cut all the roots on one side. And that's the thing you see a lot in cities. Maybe you see it more in urban and rural areas, but I feel like I see it more drastically when you get into city areas where there's these policies, the sidewalk can't be lifted by the root plate because people don't know how to walk without falling down. Fences or walls that prevent the use of a lowering device. Anybody ever encounter that? Fence grown into the tree? That's always fun. So then you got to make friction up top. You're gonna figure something else out. Things attached to or built into the tree. Well, here's some more rooting example ones. This is important because I look at this and I start wondering, well, how old are these roads? Is there any roots underneath these roads? Is the root zone just in this cobblestone area? What's going on with it? Am I going to be really worried about loading it this way or getting anything swinging this way? In more rural areas where you have like a natural flared out root plate, especially if you have a leaner, you're not worried about loading it in the direction of the lean so much because that's how the roots have reinforced themselves over time. In an urban area, different story, because if there's no root there, you want to do it. Here's a fun one. I look at this and I wonder, well, what came first here? Did the wall come first, and then the tree seeded itself? Or was the tree here, and they cut all the roots when they were putting in a wall? Well, I don't know that. I'm probably not going to take the time to take apart the wall first. Maybe that wall's holding up the whole tree. Stuff like that, you got to proceed very, very cautious. I don't think I rigged this at all. I think I just went up and was like, look, this is, you're going to get some damage, that's all there is to it. I cut it small, but that's it. And this one, you saw previously in a few slides ago, I was above it. Can't really get a lower device down there. Not that's going to be effective for up top. I think we had to stand on the upper deck, but that was the best example I could find in photos of a fence growing in the tree. Here's a lovely item. The photo's a little blurrier now that it's bigger, but this nice hunk of wood used to be attached right here. Here's the other trunk, and there's a guy wire for the pole going right through. That happens, and the J-lags were grown into here too. Again, urban style stuff. What do you do with that? Well, in that case, I left them a present. I mean, seriously, it must have been over a decade that nobody did anything to clear this for it to grow that much and that far into everything. All right, so the fundamentals that we learn in your books from your ISA publications and your TCIA stuff is dissipate force. We dissipate force by letting things run. In an urban area, the scenario that I'm sort of speaking about, you can't let it run. So what do we do? Add more rope to the system. Go guys are familiar with that too. Add more rope, more shock absorption in your entire system. The use of redirects, we'll get into that, basically opening up angles, changing the direction that these points are being loaded. So just real quick, if you caught Mark's talk yesterday, he explained it very well. I have more diagrams. Actually, I'll wait to explain it when we get to those. Work with the wood strength. You want to bring everything into compression. As this has been beaten into your heads, wood is the strongest when you're trying to compress it. If you're trying to bend it, that's when you might break it. Tension side is stronger on hardwoods, compression side is stronger on conifers. But again, if you want to break something, you're trying to bend it. If you want to not break it or make it as strong as possible, you're trying to compress it or pull it apart, but you don't have that option. Unless you work with a crane. Books like this, jam-packed with knowledge, great book. This here to me is sort of the Bible. If you have never seen or read any of this stuff or seen these videos, even though they're old, go out and get them, watch them, they're great. Everything from throw line to felling 300-foot trees is in there. And this, I pretty much consider Brian to be the grandfather of our industry, because kind of everything we do is sort of an iteration or evolution from stuff that these guys were doing, because they had nothing. They basically made up the industry because they had nothing to work with, so they had to make things to work with. This is where we get into forces. When you start changing the angle, you start changing the load on the point. This will represent your example that's been beaten into your head when you have a block just going. The line goes straight up the tree to the block and straight back down. The point that block is at, that sling, sees 200% of the weight. And you got 100% on either side. I'm pretty sure everybody knows how that works at this point. I don't have to drive this point home. The more you open up that angle, the more you change the load at that block or anchor point. You also change the direction it's being loaded. That's important because that can work in your favor or against you. And we'll look at that a little bit more detail. Evaluating tree defect, this is important. You got to be able to recognize problems in the tree, because that's going to affect whether or not you decide to load that part of the tree or how you load that part of the tree. This is a great book too. I don't know if you guys are all familiar with this one. I'm sure a bunch of you read it. All I can say is go out and get it. I'm not going to give you any spoilers. Great book for just visually analyzing a tree from afar. This is kind of another thing I think gets overlooked a little bit, is knowing your fungi when looking at a tree too, because it might have mushrooms on it and you think the worst, but they might be benign. It's not a big deal. Don't recommend that removal. If you just got hen of the woods at the bottom of the tree, it's not a problem. Familiarizing yourself with the fungus is important, and there are, they're not all harmful, and there are ones that are more harmful than others. If you see something that's, let's say, like a saprophytic, like saprot, causing mushroom, that degrades wood strength more than other ones that are maybe going to attack the tree from the inside out. So creative applications. Since we're in a different environment, we've got to take all those fundamentals that I was talking about and use it in a different way, because we've got to rely on the system we're going to build with this tree to take the weight of the pieces we're going to cut. We're not going to be able to let anything run. We've got nowhere to let it run to. We've got no cavalry coming, no crane coming, there's no other trees. This is the scenario. No other trees, can't let anything run, tight backyard, nothing but targets. We have to reinforce the tree with our rigging, which means we've got to take redirects, create compression. We've got to open up these angles in such a way that as they go up and out and down and over, whatever it may be, we've got to look at that bisecting angle in between. So rope going up, going to a block here, going out over here, that angle of pull, the angle that the force, the way that's coming in at that point, is in the middle. So if I stood here and put my arms out at 90 degrees and two people started pulling me, I'm being pulled this way, but it's going to pull me forward. Kind of get how that works a little bit? I'm sure that point has been driven home many times, but we're really going to be paying attention to that when we're building these systems. Another important thing when you're considering any, this is across the board, any climbing system, any rigging system, you want that system to be able to take the maximum amount of force that you might dump into it. If you've ever heard a story where somebody was like, oh, the rope broke because the ground guy didn't let it run. That wasn't a well thought out system because the peak force of the piece that you cut ended up being higher than what the system could take. Okay? You don't want that situation. The difference between success and failure should never be the rope guy didn't let it run. It's not the rope guy's fault. It's your fault. You're supposed to be the guy who built the system, or the person. You're supposed to be the person who built this system. You're supposed to be doing this internal math in your head. You're supposed to be guesstimating what the weight of these pieces are. You're supposed to be guesstimating the maximum force that piece is going to generate. Your system, yours, should be able to handle that. Shame on you. We're going to bring these peak forces down by limiting movement. Now, when we get to negative rigging, that's going to be harder to do. But when we're in the canopy, we want to limit movement. And this is funny that Mark spoke about this yesterday. He called it semi-static rigging. I basically, yeah, same thing. Static. We're going to gently apply these weights, not big swings, because with big swings, we don't have the room for them. In an urban, rural environment, or an area that you have more clearance in the air, ground guy can dissipate the introduction of that force by letting it run. If you can't let it run, what are you going to do? So we've got to limit movement here. So we're going to apply the weight slowly. Pivot points. That's a thing I'll explain a little bit more later, but basically I'm going to talk about the angle at which we're sending things and where we're asking this piece to go to. You really got to have like an eye for things, right? When we get to that. Here's a little clip of David Driver taking a redonkulous-looking chunk of wood to what looks like a tiny little piece of wood over here, but he's able to do that because he's got racks throughout the tree, bringing that weight, bringing that force introduction into compression. Now, there's a bit of a swing here, and that angle's got to close. He's got the room, though. Somebody's going to be able to let that run, dissipate the introduction of that force. Me, personally, I'm a bit of a nut job. I would put a bloodline on this to slow the introduction of that weight. That's just me. Don't tell me I said that. I'll rip my head up. So, this is like the fishing pole technique. This is just kind of an example of what we're talking about, working with the direction that things are applied. So what, you can read it, what it wants to do is actually stand that tree kind of up. So you're working with the power of these redirects to be able to handle the forces that we're going to introduce into the system. This is some weird picture I just picked up. It kind of harkens back to a little example. I was like, if two people pull my hair the same way, which direction am I going to go? That's kind of like that. Here's your angle right here, and this weight is pulling down, so it's pulling the red line down and also pulling these 2 points together, but this is more or less the direction of pull on these points. It's in the middle of that angle. This is some great stuff from the, let me see if I can find it on here. I wrote this down. The Victorian Tree Industry Organization. Search them out on the internet. They actually have some really good publications and stuff that they have written out for their guys to learn from. Cool stuff, but yeah, this is your basic 2 times the force on that point when that 0 angle is created by those parallel ropes. You start opening up that angle, you start changing the direction of pull, and you also change the force. You get to 90 degrees, and that force has really dropped. That direction has changed as well. So, this is what I do at home alone. We've got a point here, and we've got a piece here, and we've got this beautiful building right here, and we want to rig this out. We've got kind of it's not a bad angle. We got a little bow in the stem though. It would kind of be nicer if this was redirected back here. To open this angle a little bit, take some of that force off that rigging point. This is a weak wooded tree. We're working with cottonwood. I know a lot of people love cottonwood. So slapped a redirect right into here. And it's kind of hard to tell from the photo, but it did open that up a little bit, and now we're experiencing less force right here at the rigging point. That angle is a little bit more open. The direction of pull is at a little bit different of an angle, a little closer to compression. Here's another diagram from the Victorian Tree Industry Organization, and you can see that angle of pull that these points are experiencing. It's bringing that right into compression really nicely. Little side note though, when you are doing this sort of thing, you know, this is what's taught, and this is all well and good, but you've got to pay attention to this main crotch here and the condition that these leads are in, because even though that is bringing the angle of pull into compression, it does still pull those two together. And you notice that when you get into a little skinnier stuff, you drop the weight in, it goes, starts coming towards each other, and if that's not going to be strong enough to handle whatever it is you're putting into that system, you might experience a failure there. I've never seen it happen personally, but let's say we move that redirect from that solid bit to that skinnier bit back there, opened up that angle real nice now. Now it looks like we're closer to being in compression when we put that weight into there. But look how far it bends when we do put that weight into there. That skinny lead just went and then all the way over to the trunk. Might not be the greatest situation, because that is really putting a lot of pressure right over here. Because while we change the angle here to bring that force more into compression, we've also created an angle here. Now you see this big fat angle here. When weight is loaded into it, it wants to go towards that bisector of that angle. It wants to pull it straight out. So it wants to pull that whole portion of the tree over, basically. That could cause some problems, especially if you've got a full head of brush here, full head of brush here, and you do something like that and you start knocking limbs out onto your own head. That situation. A little bit better is like, I'm going to use this lead over here, and now we've opened up those angles, and we've shared the load between two solid points, and now I've got two, that's a bit better overhead photo. But now I got two options to swing things towards, and you'll see a bit more of the model as the slides go on. This is a little bit more overhead of a shot. And you can actually make a big difference too by changing where your lowering device is, because that will, even if it's gradual, even if it's small, affect which way that line goes, and thus change the angle just a little bit. So now I got 2 points here. This is something that you might also want to do if you have the option. This is a long sling, so I'm choosing to tie the sling off on a close by lead. When that weight and that force is introduced into that system, it's going to move this lead around, and that one's pretty much just going to be shaking around the place. But now I'm incorporating it by tying the end of my sling to it, and now that's going to come with it. I'm going to just reinforce my point just a little bit more. And in the unlikely event that I break this off, it's tied off here, so that hopefully I don't break it off too, but it'll just be that much more of a little insurance safety factor thing going on. Here's a nice tree. Everything that was over the house is much closer to the house than it looks like, and we have what would look like a great point to rig that stuff and lift that stuff, except for this. This is crazy hollow all the way down into the trunk. So what are we going to do? We're going to reinforce these points, because we still need them. We got to use them. We're going to reinforce them with this entire back lead right here. And this is, kind of hard to show in 3D what's being done here, but basically the rope goes up the side. This redirect keeps it tight to the trunk. And we come out here, and then we go over here, and then we go back here. And all that is an effort to bring it more into compression, and all of these points hopefully are going to be sharing the force of that load as we introduce it, and we're introducing it very slowly. We're going to keep those peak forces down by limiting the movement. This is going to show, this is also from the Victorian Tree Association. This just kind of illustrates by moving the lowering point again, how I just kind of briefly touched on that. That can affect the force this tree is going to see because we're opening up this angle big time. Now this only works because this tree is leaning away from where this guy's standing. Generally speaking, on a straight up spar, you don't want to have your lowering device on a different tree. It kind of sounds like a good idea because you're like, oh, I'm opening up this angle, I'm reducing the amount of force that sling is going to see, or that spar is going to see. You're also changing the direction. You're going to be side loading your spar. Wood is strongest in compression. It sounds like a lot of peak force, but it's okay because on a spar, if you're compressing, that's fine. If you did that and this thing was straight up, then you'd be pulling the spar, even though the weight and the peak force might be less. Changing direction might pull the tree over. This is okay because this tree is leaning this way. This guy's standing over here, so we're changing the angle to bring that into compression on a leaning spar. Now I'm kind of hopping around my points here. Stuff it all in your morning brains. Lifting. Lifting is great for keeping things static. If you ever lifted pieces, it's great. You make a cut, get out of the way, just lift it up. Everything's nice and controlled and slow. You're working with compression, keeping things where the wood is strongest. There are limitations, though, of the shape of the tree. D-current trees, X-current trees, a lot of times what I've run into in D-current trees is, wouldn't it be nice if we could lift that limb? Oh crap, there's other limbs in the way, there's other branches in the way. You're only going to be lifting it to a point. That can create a situation if you lift something to a point, and now it's here. Now it's got, I'm going to take it back to high school physics. Potential and what is it? Stored potential and kinetic energy. So this thing has a lot of potential energy, and to release it, it's going to make a lot of kinetic energy. If you get something half lifted, and now you have to get it off the cut. I didn't actually have any lifting tools when I worked in New York City. I didn't have a GRCS. For a couple of reasons. One, I couldn't afford a GRCS. Two, I couldn't get anybody who knew how to use a GRCS. And even if I explained how to use a GRCS, I'd probably come down and they'd take the whole thing apart. But lifting is great when you can do it. So here's these limbs, the same oak tree, just dancing over the peak of this roof. We're lifting. I ran into problems when I started to lift this, but I have to do this branch first. I can't get this branch out of the way without getting this branch out of the way, so we have to lift this branch basically into this branch, and then we're going to have to deal with that butt, and we're going to have to control it. Really big on butt lines. We'll go more into that later. I like big butt lines, and I'm not going to lie about it. So here's my little tree model in the house on Friday night. Here's my building, here's my piece that I intend to lift. And here's more or less what that looks like. I start lifting it. Now depending on where your rigging point is, that really affects everything. But you're going to have a point where it might tip past the hinge. The hinge is going to break at some point. You want to leave a big open face, but depending on your wood properties, eventually that hinge is going to break. It's going to dump into the system, and it goes for a little swing. Maybe not a big deal. I'm a maniac. I would put a butt line on stuff like that, and we're going to look at that a little bit more later. But from a climber's perspective, and from a force consideration on all your points, this is great. I go out there, I make my notch. There's no swinging. There's no peak forces necessarily to worry about. I'm cranking, lifting, making my cut, getting out of the way, hopefully, and letting it come off nice and easy. This is an attempt to illustrate, I don't have much tree to work with. I don't have many good pictures of this, but an attempt to illustrate, okay, here's some limitations. Let's say I had to take that in half, but I got this one in the way, but I couldn't take this one because that one was in the way, because it's a tree, because it has branches all over the place. So I start lifting, and it gets to a point where it won't lift anymore. It's contacting the tree. The angle is as flat as it's going to get. Now I'm just lifting upwards. So now you've got a situation where you're the climber, you're out here, you're near this, and you've got to wonder, okay, is the butt going to kick out that way? Is it going to kick out this way? Where do I have to get to make this cut to be safe? I throw a butt line on that. but you already know my style. Again, it can happen with the entirety of the limb. Taking the whole thing, this one's in the way. It just kind of trying to illustrate the point that lifting does have its pros and cons. You will run into trouble with it. It's going to happen. You just got to learn how to deal with it. There's a picture you can't really see very well, but that's it. That's me lifting a piece, and there were power lines here, so I had to lift it, but I've lifted it into another piece that I couldn't take because this piece was in the way, because these limbs don't cooperate with each other. So now it's stuck, and I got to worry about, all right, if I finish the cut, is this butt's going to want to kick out here, and this top's going to want to come back here and close this rope angle. Second line, that's how we dealt with it. We lifted it to a point. We used the lifting for as much as we could use it for, and now we've got to change up to plan B. Tip tie and butt tie, tip tie versus butt tie. Butt tying is nice when you have the room to let stuff swing, because you don't have to go out far, tie it up, you make a cut, everyone's happy. Now that's going to depend on where your rigging point is. I've come to find if your rigging point is anywhere out here, you're safer, because it's going to send it off to the side, or it's going to send it out here. Usually it's not out here because we're in a tree, everything's behind you. When it's behind you, now you got to start worrying about if the ground guy holds it. There's that moment where it flips and the butt comes up just a little bit, and it wants to come this way or that way, depending on which way you're sending it. So there are things to worry about when you are letting stuff come off brush heavy. This is also something that might be in my own head, but I tend to think that that's more force if you can't let it run, because the entirety of that weight is penduluming down. We'll compare and contrast that a little bit later. Butt tying is nice if you can get away with it, but sometimes just, this is just to show that there's precautions, there's stuff to worry about too. Watch out for that butt. This is something I like to do, and sure enough, Mark is talking about it too. Near balance tying. Basically, what you're trying to achieve with this is not a flat balance. You're trying to mimic the angle that piece is on the tree. When it comes off, it's going to kind of stay at that angle. It's a lot less movement. It's a lot less potential turning into kinetic energy. And when it's doing that, when it's walking itself around, that butt will eventually break off and kick off the stub there, but it wants to travel a lot for a lot less, because you're not really asking it to do anything. You're not swinging it down, you're not lifting it up, you're not spearing it out. It's just walking around, and eventually it just kind of pops off, and it's nice. Again, this totally depends on where your rigging point is. All right, this one's more tip tie. So it's going to come off butt heavy. And I'm sending it to the side. That's what you want with this when you have to do this. For our intents and purposes, there's an obstacle here. We can't hit this obstacle. We can't go stand over here. This is the no-fly zone. So I want to send this away. My rigging point is behind me, as it often is, sending it off to the side. And I'm sure this has probably happened to most people who have ever tried to tip tie anything. Your ground guy instinctually wants to start letting it run. What happens when you start letting it run? That turns really scary really quickly. Because it's tied out so far, this angle is opening up more and more and more, that potential energy is turning more and more and more into kinetic energy, and it really wants to spear the butt off of that right at you. That's a scary situation. That's one of those things on the fly. Everyone's panicking because you're like, stop letting it run! And he holds it, and it kicks it out right at you. Communicate. This is hard when you're working with people that aren't used to this situation, or are not used to shifting their thinking. Ground guys that are used to letting it run because they think they're saving you. Don't do that before it's off the cut. So you really got to communicate and have a conversation if you're trying to execute this maneuver, trying to get this thing to come off butt heavy. Because if they start letting it run, that's pretty dangerous. And in this, again, we're still on the tip tie topic. This is when you screw up. and you cut through your hinge, and the whole thing wants to go bang right at you. I will actually take this over the ground guy letting it out, because that's more of an angle and more potential energy turning into kinetic energy, because this is a shorter gap to close. It's a smaller angle, so it brings this thing in fast, but not as deadly as the other way. And sometimes when they are on the ground, they're attempting to correct your mistake, and so they let it run, so that tip flips at you real fast still. You're going to want to avoid that. I tell the ground guys when I'm trying to execute this, and this is how I fix this, is put a butt line on it. I'm going to convince you, by the end of this, you're going to go out and you're going to buy a new rope just to butt line things with. I'm telling you, if I've done my job, you will butt line everything that needs to be butt lined. I didn't. Ryan's out here, he told me he doesn't butt line stuff. I think I see you out here somewhere. You will. You will. Here's me using a butt line. Setting off to the side, everything is controlled. I love it. And even if I screwed this up, if I cut through my notch and that thing wanted to spear towards me, it's not going to come nearly as fast. That butt line is just going to keep it there. So the top's not going to come at me. What's going to happen is it's going to go to one side or another. It has to. Or it's going to sit on that cut, and I'm going to have to kick it off. And I'm right, I know what's coming. Boom, here it comes. Boop. Not a big deal. Hold both of those tight, more control. And this is an urban environment. I should stress that. You're probably not going to block tie stuff when you've got tons of room to let things go how they need to go. Butt tying is for tight quarter rigging. This is sort of to illustrate, let's say I wanted that to come off butt heavy, and I guesstimated the balance point wrong. And by the time it comes around, oh, I was dead wrong. It's actually brush heavy. But I was safe the entire time. I had control of it the entire time until they started letting the ropes out. Everything was fine because we had it. We got it to swing. We got it to clear an obstacle. We kept the butt from popping off and hitting me, and now we let it out. To get the least amount of travel here for when that does break off, because if you have guessed this wrong, this butt does want to move, and it's pretty obvious you guessed it wrong when it breaks off the cut. You want to keep that distance really nice and tight. So I should have this sling tighter, and I should have this closer to the butt. But here's a prime example. I knew this was going to happen. We got power lines over here. We're walking this piece around. I couldn't get far enough out on this piece to make it tip heavy, but I could get far enough to get this thing, to get enough leverage for that rigging point to walk it around. Now it's going to break off, and it's going to want to send the butt my way. But look who's helping me out right here. Good old butt line. And that's going to limit the movement. That's what's going to keep you safe. That's going to give me a chance, actually, too, to make that cut and get out of the way, too. When it does break off, the distance of travel is pretty much this. So if you can make this as small as possible, you're going to get less that it wants to punch you in the chest. Okay, we're going back to that same lead that I was lifting over our lovely building that you can see right here, a lovely dawn redwood shaped building. We don't have lifting capabilities for whatever reason that day. I don't own a GRCS yet. So I'm going to have to tip tie this thing so it clears my obstacle, and I'm going to have to send it to one side or the other. The rigging point is right behind me, probably right in line with my climbing point, because that's all there is in the tree. So we got to work with it. Then I'm going to set my notch here, maybe have guys pull it, and it's going to walk around. Now at some point, depending on your wood species, depending on your hinge, depending on a lot of things, it's going to break off. It's going to skid the side here, or the butt might try to kick off the end. That's kind of a dangerous situation. And that's why a lot of people, I think, don't like tip tying stuff. It does. It creates more dangerous situations. But when you're in an urban environment, you have to. You have to not hit that obstacle. This is stop saying it's so easy to say. This is balanced for the purpose of not having it be balanced when it comes off. I'm trying to mimic that angle, so I'm getting less travel out of my butt. Why? Because I'm changing the angle that rope is coming to that piece. That balance tie, or near balance tie, is bringing that rope angle just a little bit. I'm going to be able to achieve that swing and get all that clearance I wanted, but the angle is going to be that much not steep, less steep. So when it walks itself around and wants to break off that hinge, the butt's not going to travel as far. It's still going to kick off and it's still going to move, but it's not going to be as potentially violent. What would I rather do? Put a butt line on it. And that's going to limit the movement. I'm going to walk around, it's going to break off at some point. I'm going to be swirling like this, because I'm going to be watching that very carefully. And I know, though, when it comes off, the amount of movement, the distance that it's going to travel is going to be equal to the length of basically the neck of the sling and how close you manage to get that marl or half inch you're rigging. You got to have an eye for this stuff. Like, let's say I decided I'll use the other rigging point to keep this further away from me. It's going to swing further away from me. I don't have to worry about the butt, because now my rigging point went from behind me to over here now and out. So the whole thing's going to go this way, and it's going to be safer for me, but my objective is to not hit that lovely dawn redwood stump-shaped house here. Is it going to clear? And you've got to calculate distance in your head visually, it's tricky, it's tough. You got to have an eye for it. And it's not just the distance from the sling to the point that you tied it, it's the distance to the very tips. This has got some limbs on it, so it wants to roll, depending. Is that going to clear? It's $1 million question right there. That's an expensive dawn redwood stump house. Do you want to play that kind of game? Also, do I want to deal with making that thing pivot with the point behind me? So these are considerations, and these are things you got to deal with when rigging in tight quarter situation. Am I putting the house more at risk? Am I putting myself more at risk? I would say put the house more at risk if you can, because you are more precious than the house. This is just a little diagram, and now we're going to talk about letting things go into a swing. Because sometimes it seems like you have the room to do that, and when you really got to consider it. So here's our angle, and here's the direction of pull. That's sort of like the midway point, right? And there's sort of a distance here to where your piece is and where you're going to cut it. When this comes off, it's going to want to travel a near equal distance in the opposite direction of that angle. So sometimes it's not necessarily what you're trying to avoid over here. If you're going to let things swing without a butt line in a tight quarter situation, what's over there is a problem. Especially if you're butt tying stuff and you got this tip out here. Because this length right here, when it swings, it's not just going to go like this. It might flip up and be in the air, especially if you can't let it run. And this is in 3D. This is not in the 1-2-dimensional plane. This thing walks itself around and flip. I was playing with this for hours, and I need more visitors. Illustrating the same thing, this is in decurrent trees when you start getting to tops that are the same height, and you've got to rig something to that rigging. Well, you can't go any higher for whatever reason. This is dead, or not, it's just not going to support it. When you let that fly and let that swing, it's going to close that distance, travel an equal opposite distance over here, and that's just to where it's tied. You also got this tip to contend with. That's a pretty gnarly swing. If you can't let it run, if your ground guy can't dissipate that force, that's a lot of peak force right here. That's also a lot of distance. I don't like, for me personally, I don't like doing that. But I know some of you guys get to work with people consistently, and you guys get to build like this good rapport. That's one of the downsides of being a contract farmer. You don't necessarily get that. So maybe you have a great ground guy who can let that come off and then start running immediately, so you can land that piece over here rather than watch it go and hit the telephone cable and knock the bird feeder off. Let's slow down. Whoa, whoa, whoa. Me, I gotta rely on my butt line. So I'm gonna put a butt line in this to keep it from violently swinging over here, to take the responsibility out of the ground guy's hand and then put it into mine. This is a great place to use the aerial friction device. If you have one. If you don't, you have another ground guy who will be able to, and another way for him to control, like if he has another lower device where you can take a wrap on something. This will end up seeing most of that weight and that force, because that angle is so steep, it probably won't even come to play until it gets like down here. And you can actually play around with this. You can go a little bit higher, and that'll, if you saw, When this flops down, it's straight up and down. If I go just a little bit higher, I get a little more clearance when it does actually flop, because that line wants to take it before it's completely off the cut. That's kind of negligible, but when you're talking about like inches of trying to clear something, it does help. It does make a difference. Type of equipment that we use in CANOPY. Well, I'm sure you guys are all familiar with all this stuff. Pulleys are great for lifting. They're great for mechanical advantage. They're also great for negative rigging and the whole 9 yards. So the only downside of the pulley is because there's less friction on it. These points see just a little bit more force. But if you've taken your redirects correctly and you're bringing things in the compression, it's not that big of a deal. It becomes more of a consideration when we get into something like negative rigging, where we're dumping heavy weight that we can't let run, and there's nothing we can do about dissipating the force except how we build our system. Rings are great, you can beat them up. They're not so great for mechanical advantage just because that little bit of extra friction. You can still do it, you just have to put just a little bit more force to get them to lift stuff. Aerial friction devices, I like them. They're great for if you can't get a lowering device on the trunk. Also, natural crotch rigging when you can't get a lowering device on the trunk. We'll go into that a little bit later. If you need to control an additional line, like I did with my top example, that's the same height as my terminal rigging point, and I don't have a second lowering device, let's say. Aerial friction device is great for somebody controlling that additional line. They're also great when you need to dissipate force at the rigging point. So, oops. That's a skinny top I'm in. It'd be nice if the peak force was brought down just a little bit, just so I get less of a wiggle. Natural crotch rigging, don't snub your nose off at it. I do it all the time. It's great, especially if you're not letting things run and you're not burning ropes and you're not burning crotches. You just got to make sure that you're selecting the right rope for it. And I'm not a rope expert. You've got rope manufacturers and experts here at your disposal. Ask them questions. That's why they're here. 3-strand and 12-strand, 16-strand, as is my understanding, are probably better suited for this because that's all it is. The load is just the cover. The core is only there to keep it round. Double braid shares the load between the cover and the core. So if you're burning up the cover while you're rigging it in a natural crotch, the rope is not going to be able to handle that force you're putting into it like it's supposed to, evenly between the cover and the core. And somebody who knows more about ropes can elaborate on that. I'm not a rope guy. Here's your equipment, here's pictures. A little note, pulleys are better suited for overhead work. Blocks are for overhead work as well, but not negative rigging. So you don't want to be negative rigging into this thing, but you can negative rig into this all day. Here's some lovely aerial friction devices. Here's my personal favorite. You didn't need to hear that, but you just did. Here's a safe block. I like this one because this is of the aerial friction devices. This is the most heavy-duty one. This will take the larger rope diameters, and this can handle the most abuse. The friction is dictated by the diameter of the rope you put into this thing. Here's a blurry picture that looks more blurry because it's bigger on that screen. But basically a situation where we can't get a lowering device on this tree because the building is built right up to it, the fence is built right around it over here. So fortunately we're able to stand on this roof, otherwise I don't know how we would have done this. Probably would have found a way. But we have to use aerial friction to do the lowering. Now, this is some old school stuff right here that is not really taught so much anymore, and it does have merit, and it does have value. These are just natural crotch wraps. You start wrapping towards the crotch. This allows you to add or take off wraps as needed. This is beautiful. This is super simple. This is not gear intensive. If you need a butt line to control the swing, and you don't have a device or maybe an extra ground person, or they don't have anywhere to create friction on the ground, you do a couple wraps. It'll just stay there. You could wrap it off tight and then take the wraps off, and you could be the guy feeding it. Give you something to do while these guys are trying to take the tip and move it to where it's got to go. Some precautionary things with this, though. This will be affected by the direction this is being pulled or sent. So if for whatever reason your rigging point is that way, if it's away from the actual stub or butt, and it starts traveling that way, it will pull the wraps off. So watch out for that, because I learned that the hard way. As with most of these situations. The reason I feel like I can speak about any of this is because I did all this, and I messed it up a couple times, and I learned from it. Here's me just using some aerial friction in the backyard somewhere because you couldn't get a lowering device, and there's vines everywhere. It's a nightmare. So I have an overhead natural crotch rigging point, and the piece is about to get just a little bit bigger, and I'm creating essentially a redirect too, because I don't want it to swing back over here. I need it to stay out here, so I'm just going to take a half wrap and combine with the crotch friction, the friction over here. I can achieve that, and then I'll just take that wrap off, and then you can pull it to the ground. There's some in the tree lowering device made out of a stub. Taking wraps on it that you can easily take off and just lock them on it. And I do this is more of a lower weight sort of thing. I'm not doing big pieces with this. And you were using 16 strand, 12 strand, and 3/4 or 3-strand rope for this. They generally have a lower workload limit. So your piece is gotta be smaller. Here's the thing to watch out for with that. That friction, if you are able to let it run, will burn right through some bark, right into that cambium layer. So you don't want to do this on something that you intend to retain for any reason. Lowering devices, we'll just go over this really quickly. You got your bollard style, ratchet or fixed, GRCS, Hobbs, that robot thing that transforms on your tree. There's some fixed bollards that Stein makes a bunch. There's your quarter wraps everyone's familiar with. I knew there's something I wanted to talk about with lowering devices, and I can't remember what it is. It'll be a mystery. Okay, now we're at the wood. Negative rigging, when you can't let it run, is a situation because it is, from what I know, is the highest peak force you're going to create because things are going to be dropping into your system and you're going to be catching things. And they're going to be the heaviest chunks of the tree. They're the trunk. And by the way, if you can cut it and let it fly, let it fly. But we're in an urban environment, so the likelihood of this is not very likely at all. In fact, it's going to be the opposite. You're going to have to be cutting things in little small pieces and quarters and rounds, but at some point you're going to be too high on the trunk where even cutting it into a small bit, if you don't have actual like dirt or something, and you can create crash pads, but they only work to a point. You got to get lower on the spar. So more often than not, you're going to have to rig some of it down. We'll look at these different systems: double blocking, triple block, multiple blocking, dual systems, twin systems. What I mean by dual systems: 2 ropes, 2 blocks, 2 lowering devices, pioneered by Reg Coates, as far as I know. Twin systems, same thing, only you're double blocking in each one of those systems. Let's just look at the pictures, they make more sense than me talking about it. And here's something I yanked off the Petzl website. Your basic setup, straightforward, real nice. Everything here is done perfectly. He's got a little air time to let it run too, that's going to be great. Now here's Reg's dual system, 2 blocks, 2 ropes, and down there probably 2 lowering devices, or his trademark double bollard lowering device. Here's a little less blurry, but darker picture of the same thing. Now what that's going to do, it's not necessarily going to dissipate the force on the spar itself, but it's going to take some of that work and take some of that force off your components. So it's going to be nicer to your slings, it's going to be nicer to your lowering device. If you got 2 different lowering devices, if you've got 1 lowering device, it's still going to see the entirety of that force. But it's going to be easier on your ropes, and it's going to be easier on your block. And if you have something that weighs more than a single system is going to be able to handle, which starts happening when you get into fatter wood, our dual system is nice, because it's going to spread that force between more components. It's more rope in the system too. Here's David Driver setting up something similar. Here's David Driver setting up with X-rings, and X-rings were newer on the scene, and they're great. They add a little bit of friction into this whole equation, so that dissipates the force just a little bit more. And there goes that Buick-sized piece coming off the top there. Now, around, what was it? April 2015, Garrett Tucker-Jones did an article on double block rigging, which was the first time I ever saw it. And it's the cat's pajamas, I gotta say. Look at that diagram. You're taking down the force on the rope and on your rigging points here. So this is your traditional system. The piece weighs 100 pounds. Your lowering device is going to counterbalance that 100 pounds, so the total is going to be 200. These are just example numbers, but we're talking about peak forces too, and we're talking about not being able to let stuff run. So that 100 pounds arrested, just snubbed off, which is what's probably going to have to happen, is probably going to turn into like 1,000 pounds or more. Now you've got this double block rigging system that's going to reduce the amount of force that the lower device sees and cuts the amount that the block or whatever device you have here sees in half. Then you terminate the rope here, so the spar still sees about 1.5 times the force. Anyway, when it gets to 1,000 pounds, then it's only 1,000 pounds here, not like 2,000 like it would be in a traditional system. So you're putting more rope into the system, you're adding more components, and you're sharing that load, and you're taking these peak forces down. That's great. I love doing that. It makes me feel good. Here's me feeling good. Double block rigging a chunk with X-rings. Feeling fine. Here's me doing it with 2 safe blocks. Now, the safe blocks are great because they add more friction in the system and they start bringing the peak force down just a little bit. We played around with this. 2 safe blocks is not actually the greatest because it's a pain in the butt getting it back to the climber for the next setup. And when this flips over, there is a little bit of rope on rope. So there is a little, there can be a little glazing. So we've kind of gotten away from that. Then I saw this on the Instagram, John Uselding. Twin systems with safe blocks. And I was jealous. I go, I want to do that. So I searched high and far and wide to find a spar that I get to do this too. And eventually I found one. But this is a great idea. This is building upon Reg's idea of dual systems and then doubling up those dual systems. So we're adding so much more rope and so many more components into this system. Because where he wasn't able to let it run either. He's in a graveyard of some kind. You don't want to be knocking over tombstones. And here it is with just all X-rings, more rope into the system, more slings, more things set to basically absorb that force, because it's going to be a big force. You could go smaller, and that's probably a more practical thing to do. I'm not advocating doing this. I'm just saying if you get into a situation, because eventually you're going to get into some sort of diameter where it almost makes sense to just make it a little bit longer instead of taking these shorter things that you're trying to tip over, because shorter lumps are harder to tip over. But if you're going to do that, make sure the system that you're building is able to handle the highest peak load, the most force that you're going to generate. And this is me getting carried away. This is me seeing this and being like, I want to do that too. And there I am doing it. But I didn't necessarily, I could have done that in 2 pieces. And I mean, this didn't take that much longer to set up because I knew how to set it up. I knew what I wanted to do. But not advocating this is probably unnecessary. I have been accused of over-rigging to amuse myself in the past. But I'm not the only one. Then this guy, Daniel Mendez right here that my green pointer is on, saw that, did the same thing, and then he one-upped us all. And this photo's a little blurry because I zoomed it in. But he made a quadruple block system and then tied it off at the ground, adding more rope into the system and now making more, I guess what you would call reverse mechanical advantage when this thing flips over to absorb that peak force. And he had a purpose for having to take this that large. They're going to take the wood, they're going to mill it. So there was a reason behind him doing this. He wasn't just doing it for fun like this guy. Great job, Daniel. You inspired us all, so we were like, we would be like Daniel too. So we started triple blocking just for the hell of it. just for fun. There's David Driver triple bucking in a demo, and there's me just doing it because I want to be cool. And now we've got, you know, fun's over. Now we're to that point on the tree, or you're at a tree where somebody decided to build a garage into it. You're not going to be able to rig anything else. At some point, you're going to get to this section of the trunk that it's no more fun and games. It's all manual labor. You're going to have to cut it small. You're going to have to use crash pads. That's a screenshot, but there's that point in the trunk where we can't lower anymore because the stretch is going to hit our target, and we can't just throw it down because it's still high enough where it might break something. You got to create crash pads. That's what we did here. I think there's a tire in there too. Pallets, brush, tires, whatever you got. I will say, don't put a bunch of logs, just logs, because to me, that if you're working on concrete and your phone starts going off in the middle of your presentation, if you're working over concrete, that's just hammer and nail. That would maybe absorb some of it, but it's the wood you're sending is the hammer smacking that nail into your concrete that you're trying not to crack. You're going to crack something. So get something that's more shock absorbing, like a bunch of brush, pallets, things that are meant to break and have a little bit more airspace in them, I guess. And tires. Tires were great too. This was no fun, but I did have a little bit of dirt there to throw it into, so we didn't necessarily have to create it. And it's smaller. It's a lot smaller. I have been experimenting with other things because there are situations where the ground is made of lava and we can't throw it down. This was a terrain problem. The thing is super steep, but I gotta throw this somewhere, and you know, even if I quartered that and chucked the quarters down, they're still gonna bounce and they're still gonna roll just because it's a terrain problem. So I don't know if you can tell, but I got my pointer dyed on me. There's the sling, rope's going through the sling, and I tied it around this way because that thing is so short. I'm not able to get a rope around this way without it coming off immediately. So I've gone this way with it. Pain in the butt to set up. There's got to be different ways to do this, and I put that out to you, to the world. Maybe somebody comes out with something cool by seeing something stupid that I did. It worked for what I was doing at the time. It kept the piece from taking off down the hill. And that's what I had to do in that situation. Now, all this only works to a point, okay? We can only do what the tree will allow us to do. So, identify your defects, know your wood rotting funguses, because that's gonna, if you show up to a tree that's covered in saprophytic rot, don't try to break anything, don't try to climb it. You gotta tell that person, like, look, you let this thing stand dead too long. The only thing we can do is fell it. We can't get any equipment to it. You're going to have to deal with some property damage. I'm not putting myself at risk for you. You got to know the subtleties of each species, wood characteristics, seasonal hydrology. That's important because water does affect how the wood behaves and different times of year in different areas. Be safe. This is chess, not checkers. Protect yourself. Always have a way to escape all those cuts. You know, whenever your rigging point is behind you, whenever you got to swing things, press something and killed it. Oh, it's back. Always have a plan to keep yourself safe. No tree is worth your life. It's not. Just walk away. Walk away or tell them, look, I'm going to have to break some stuff. If you want me to do this job, stuff's going to break because this thing is too dangerous. We can't get equipment to it. Or walk away. I've never been smart enough to do that, but I encourage you to do it. And that is the end of my presentation. Do we have questions?